Hello everyone, welcome back to my channel. I'm Tepin and you're watching Tepin's Lab, and today we're going to learn how to submit partial coding genes in NCBI. We know that it is really easy to submit nuclear ribosomal DNA and all those DNA, but to submit a protein coding regions or partial protein coding genes, it is slightly complicated. So this video is for those people who are struggling with submitting the protein coding or partial protein coding genes in NCBI for Genbank ID. So let's get started. You can go to here, submit, and I'm going to uh, walk through all these things that you need to do before submitting. So I'm submitting the eukaryotic DNA, and the protein coding region or the partial protein coding region that I'm submitting is a translation elongation factor gene. This is the sequence. It is 554 sequence long. You have to choose this coding region feature. Click here and start Bankit submission. You can put your details here. Put the order sequence name. You can put unpublished here because eventually you have to update your information after the publication. Sorry, I have pressed this one. We have to continue. Press Sanger sequencing if you have done, and these sequences are assembled, so you have to click here. If you have unassembled sequence, you have to click here. And release date, you can choose any date. I'm just choosing this one. Molecular type, our DNA is genomic DNA, and it is a linear DNA because it is eukaryotic DNA. So you can choose your file here. Now press continue. Press continue. You can all put all the details here, original data. You don't have to do anything here. Source modifier, you can put altitude, that is 355 meter. Specimen voucher, we have to put it here. FR 270. You can add another if you have something, for example, geolocation you can put. It is from India. You continue. And here you have to do certain things before submitting. So we have coding region. We are providing intervals. You have to provide, even if you do this, you have to provide this protein sequence data. So that is a quite complicated things. So first I'm going to show you how to do protein intervals. You can click here, add, and you will find things like this. So what we are going to do now, how we are going to specify our introns, exons, and all those stuff. So in this lesson we're going to learn that. So first thing first you have to do the thing that is important, that is you have to blast your sequence. So this is my sequence. I will blast it here. So after the blast, you will find some similarities with the species. You can see here all the species that is similar to my species. So now you have to go to this alignment here. You can see this is your sequence from it is from your sequence one. It is taken in the query, and and from sequence 38 of this species it is taken. It is aligned with your sequence from 38 from the 38th sequence of this species, and from one sequence of your sequence. You can see this graphic summary here. You can see this is the query sequences and all the sequences here, which is aligned, how they are aligned and what they are aligned. You can see graphically here. And this is mentioning that from sequence number one, this is your sequence number one, and this is the sequence number 38 of this species. It is starting with sequence number 38. This is because this is important in case you're work and if you're you're going to work through here. But since we're working on our sequence, we will focus on this sequence. So you can see all these sequences aligned or not aligned, where it is different or similar. Now you have to click this CDS function features here. When you do that, you will find that this showing all the these are all the protein coding sequences, genes which are coding these proteins A, I, L, all this alanine, whatever the guanine, whatever it is, this coding this all this amino acid up to this three sequence. And after this sequence, all the sequence you see, they are not coding anything because they are introns. So the exon that we have, or the protein coding genes that we have here, we have to mention that here. I'll talk about this plus and minus string later. No, partially this one is later, but you have to click here and mention the gene regions that are coding for amino acid or protein. So you have to mention that. So you have to count from here. For example, this is your one sequence. It is mentioned here, but you don't know what is this, what is also this three, what is this position of this G. So you have to count from here. For example, this is 121. You know this is 121, then 122, 123, 124, 125, like that. You have to count up to this, because from here it is your introns, the non-coding region, which is starting from here. So you have to count up to here, and I know this is actually 144 because I've already counted. Like that, you have to count from here. Then this is your from here it start your coding, the exons starts from here. So you have to count from here to here, and I've also counted that it is something around so let me count it if you are confused. For example, let's say this is your 181, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 7, 98, 99, 200. So from 201, it's your protein coding gene region. So you can see from 201 to 337. You can count it here. If you go from here, it will take longer, so you can come, come from the opposite side. So 360, this one is 360. You can say 359, 58, 57, 56, 55, 54, 53, 52, 51, 50. 49, 48, 47, 46, 45, 4, 43, 42, 41, 40, 39, 38, 37. So from here, it's the non-coding region start. So up to this 337, we have our coding region. In the same case, we can do the same thing from here. And I've already counted that from here to your last sequence, that is 543. It's not mentioned here. You have to go to your sequence to see the last sequence. What is your last sequence? For example, you can see my last sequence is 540, 1, 2, 3. But here it is also only mentioned 534 because it is aligning with your the 534, and after that maybe they don't have the sequence. Maybe the sequence are not available for this query sequence, so they have interrupted it here. But the end of your sequences, for example our sequence is 543. So from here, from this sequence to the end, that is 543 we have, and this is the region, that is 393 to 543. So now that we have all the exons, we can put it here. For example, 1 to 144, it's exons. You can see here, it's 1 from 144, it's your exons. From 201 to 201 to 201 to 337, 337. From 1 to 337, we have our introns, and from the next intron is from 393 to 543. 393 to 543. 543. Now we are done with specifying the exons. The next thing that we're going to do is find out what is our strand. Is it plus or minus or whatever it is? All these sequences are plus or minus. To do that, you have to know about your protein sequence. For example, the protein sequence that I'm working is translation elongation factor, and it is a trans TF1 alpha gene. So you can just copy this and paste it here. So I've already pasted this one here. So if you paste only this one, then you will find many translation elongation factor already here. For example, this is of Homo sapien. We have Danio, Rario, and all the Drosophila melanogaster, all these things. But since we're working on fungi and especially the Basidiomycota, so I'm concerned with Basidiomycota. So I put this species, which is you know, one of the, you can say, model organism, like one of the model organism, because based on this species Schizophilum commune, the sequence that I have amplified, the primer was generated based on this species. You can see from here, this is the paper that they have worked on, and they have prepared the primer that I've used to amplify the sequence that I have right now, that I'm submitting. So this is the mm, sequence. So you have, in order to know, you have to also, don't forget to keep this gene here. Don't just search this, press gene here and then schizophrenic all this thing and then search it, and you will find something like this, name slash gene ID. You can open it, and in here, after opening, you will find that this is your gene. Okay, you can see this is translation elongation factor 1 alpha gene of the species Schizophilum commune. So you can see this is the gene, and this arrow you see, this arrow indicates your, what is the sequence. For example, if it is negative, minus, or plus sequence. If the arrow goes toward the right, then this is your plus sequence, and if arrow comes toward the left hand side, then this is your minus sequence. For example, all these proteins are minus sequence, and all these proteins are plus sequence. So our protein is this one, and this is a plus sequence. So you can keep plus, all this plus here, and if your entire sequence you're mentioning, then you will find something here like plus minus, then you can choose plus from there. And after this, now you're done with this, and we know our sequence is uh, partial sequence. Why? Because the primer that I'm using, I'm just going to show you now, the primer that I'm using, that I've used to amplify my, is this one. So the primer has amplified only 595 to 1160 region. It is somewhere around 600 or 443 sequence long. So this is the sequence. This is not complete sequence. Complete sequence would have been like from 1 to whatever the end of the sequence, because there are other primers also I've been using. For example, this one amplifies. This is the same uh same gene amplifying primer. You can see this is same elongation factor 1 alpha. This is also elongation factor 1 elongation factor 1 alpha. But this amplifies from 983 to 1567, and this amplifies 595 to 1160, like that. So now we're done with that. So we know our sequence is partial because it is not incomplete. So we have to click here, and now we have to mention what is the reading frame. For example, open reading frame, we know we have three open reading frame, 1, 2, and 3. Open reading frame, you must know about that. Okay, I'm not going to explain that. Then click one here and then press. This is a partial sequence of partial, and you don't have to do much things about here. You can write this is a partial coding sequence. This is a partial CDS of transcription reduction to the 1 alpha. Now we're done. Just click accept. So it has worked, but in some cases it might not work in. Okay, okay, I have to reboot it here. 2012 337, and another one is 393 to 543, right? Okay, right. So in some cases okay, sorry, I have to remove this, all these things, just to show you. I just want to show you something. I'll show you right now. Just add features, coding, providing intervals, add, and we have to specify sequences. 144, 201 to 337, and 393 to 543. Yes. So you can click this one here, like previously what we have done, partial. For example, if sometimes what happens is that if I'm just going to show you, for example, if you choose one, for example, I'm choosing two, but for example, if you choose one open reading frame, then you might find an error like this one. Okay, it is also accepted this one. I will just remove it again. Try the next open reading frame. It might not work in that case. So what I'm trying to do is, sometimes what happens is that the open reading frame that you choose also doesn't work, because that open reading frame also specified the introns, because open reading frame also specifies for some reason sometimes the introns. In that case, you have to change the open reading frame, like what I'm doing right now. Since it is not showing error in my case, so I'm just working, but so it is good for me. But in some cases, if the error shows, you just have to change the open reading frame. Okay, you don't have to do anything, you just have to change the open reading frame. You can go. You can see something like this will sometimes will occur, like everything is correct, you have mentioned correctly the position of the exons, but still it is showing something like contains internal stop codons, which is biologically correct. Then you have to change the this open reading frame. In my case, I'm just going to choose one and then accept. And you can see, but don't just continue right now. You have to also copy this some of the sequence from here and open this sequence which you have used for analysis. For example, this is topic of protectioners. Open it, and you will find that there's also some amino acid sequences here. If you search it here, then it should match, because most of the sequences were matching, right, from here to here. Almost these sequences were matching, and so this assumption is to make sure that you're using the correct open reading frame. So just copy it and paste it here. If it is matching, then your open reading frame is correct. Because sometimes if you choose the wrong reading frame and it is accepted, but the protein that were sorry, the amino acid sequences that were generating from the sequence that you're submitting might not be correct. So confirm that you have to copy and paste like this to check if the sequences are sorry, the open reading frame is correct or not. So if you can search it here, copy and paste it here and search it here, it it is matching, then okay, your open reading frame is correct. What is the information that you have collected from here, and you have done that and choose the correct open reading frame, and you can copy this one and paste it here, then it should match because you have taken it from here, right? This is the other species. It should match because it is matching here, so it will match here. So it is matching, so the open reading frame that you have put is correct. Now you can submit this one. Everything is done. You can just continue, and you can put all the information that you need, and you can check here if you have all the things is correct. For example, this is a tropical species with accession number, this one. And also choose, for example, submission category, original organism. I'm just checking if I mentioned the, okay, I have not mentioned the specimen voucher. You also have to mention that. Now we are done. Continue. Okay, now we're done. You can see our specimen voucher is, yes, 2470. For specific genomic DNA, of course. Altitude this collected from India. This is the collection date, and these are the people who have collected this. And this is a transcription reduction for 1 alpha, and this is the coding regions. So now we're done. We can now submit this. Click final submission, and we're done with the things. So this is how you submit a partial or coding, protein coding genes, partial protein coding or protein coding genes, if it has introns. So thanks for watching. I hope you learned something new, and don't forget to hit like, share, and share to your friends who need this, and subscribe to my channel, and also comment the queries that you need. So thanks for watching, and see you in the next video.